Okay, very good evening, dear participants. Welcome back to the day 4 session on a 7 days workshop on data analysis using SPSS. Hope for the past 3 days you're all learning statistical tools and how to do the analysis and how to write the interpretation for the output that you have got. Right? Okay, fine. So it's happy to back the session on the day 4, and then only as of now only 23 participants are joined. Okay, so others let them join. So before that, we will just take a 2 minutes to recap what we have been discussed in the last 3 days. So can any participants can put it in the chat box that what are things that you have learned the last 3 days? Can you give me an answer in the chat box quickly? What are things that you have learned? So meanwhile, the others will keep joining. What are the analysis that you have learned in the last 3 days? First day it was the introduction. So of course everyone know that what type of a scales, what type of a variables, and what type of analysis you have to do. Okay, and the second and third day, what are the analysis you have learned? Can anyone can put it in the chat box? Yes. Can I get some reply? Just we'll have a recap of 2 minutes because participants are yet to join. So let them join so that I can start the session. Can anyone can tell me what are the analysis we discussed? What is the second day? What is the analysis you learned? Because that is a basic analysis you required for your research, right? To check that whether the data is reliable or not, you have to do a reliability test as well as a normality test, whether data are normally distributed or not. Followed by that, you learned about descriptive statistics, right? What are the data that are collected? How to summarize that data, right? For the descriptive statistics, ma'am has explained you. Followed by that, yesterday you have learned one of the significant tests, right? Under significant test, you learned a t-test, two independent sample t-test, and then paired t-test, right? I hope you learned this two important analysis. So according to your type of data and the type of variables, you can decide whether I can use a t-test or not, right? And the descriptive statistics is common. Okay, what are the data that are collected to summarize your entire data, okay, and then to give a single information and then give an interpretation for that, you need to have a descriptive statistics. Okay, fine. So hope around 30 has joined. Okay, fine. Okay, I'll start sharing my screen. Okay, can you see the PPT?
Yes, sir.
Okay, fine. Thank you, sir. Okay, so welcome back to the day 4 session on factor analysis. Right. So today we are going to discuss about the very important analysis. Okay. Now, can anyone can tell me what are the analysis you learned in the last 2 days? What category of analysis it is? Because already in the first day I told you there are 3 ways. Are the one is a bivariate, univariate, bivariate, multivariate. Right. So last 2 days you learned what are the analysis you learned? T-test, descriptive will comes under which part of analysis? Can I get answers in the chat box, or you can unmute and you can say yes. So if you give me an answer, it is easy for us to interact. What are the analysis? What is that? It is whether it's a univariate or bivariate or multivariate. Can anyone?
So you have an option to unmute yourself. So if you wish, you can unmute yourself and you can answer. And if you want to put it in the chat box, you can put it in the chat box. And Somasundaram sir, some of the people are chatting in that univariant and bivariant.
Okay, very good, sir. Thank you. So univariate and bivariate, right? In the last 2 days, you learned about univariate and bivariate, and the rest of the remaining days, you are going to learn about the bivariate techniques only, right? But can anyone can tell me what is the analysis that we are going to learn today? Factor analysis comes under which part of the analysis? Can anyone can give an answer? Factor analysis comes under which part of analysis? It is a univariate or bivariate or multivariate?
Multivariate.
Is that multivariate, sir?
Multivariate. Very good, ma'am. Super. So last 2 days you are learning about uni and bivariate, and the rest of the days you'll be learning bivariate analysis. But today what we are going to discuss is it is totally it's relevant to multivariate analysis technique. In among the various multivariate analysis technique, a factor analysis is one of the important technique where most of the research scholars are started applying in their research paper nowadays. Why the factor analysis comes into the part of this statistical research analysis? Right, in those days, right, we will be very difficult to get the literature review. It is very difficult to get the variables, what variables, which items, which factor, which term we need to use for the research work. But nowadays we have a lot of sources that through online we can able to get n number of literature review articles, so that through reviewing various articles we can able to gather a lot of variables, lot of information. For example, if you want to know about the customer perception towards online food delivery service, there are a lot of factors. Okay, payment, delivery service, types of restaurant, types of dish. Right, there are many variables, are there, many factors are available. You don't know which variables, which factors is apt for your research work, because you may do a research on a particular area, but your targeted respondents may be different, or the target locations may be different, the population may be different, or there may be variations, small variations in your research work. So in that case, sir, I got many variables. I have n number of variables through the literature review, but I don't know which variables exactly suit for my research work. Can I take this variable? Or there are some variables which resembles the same synonyms. For example, if you take work schedule, right? Working time, working hours, shift time, extra time, extra work time, all these things talking about the working time or the work schedule, right? Can I put which term I need to put it, right? So in those cases, to confirm or to explore your factor and to get a confirmation that out of this 10 variables or out of this 20 factors or 20 variables, you can take this 5 variables, or you can compress to 5. So factor analysis, in simple terms, if you want to say, it is called as one of the techniques, statistical techniques, which is used for reduction of the factors or variables. So today what we are going to learn is a very important analysis, okay, under multivariate analysis technique, right? So first we will cover the theoretical part. Theoretical part is I'll explain you what is a factor analysis, right? Under factor analysis, what are 2 types of factor analysis are there? And after that, I will show you how to interpret for the factor analysis. Because in factor analysis, you have to interpret for the 5 outputs. It's not like one output you will get from the factor analysis. There are 5 outputs are there in the factor analysis. For each output, you have to interpret, and finally you have to conclude that which factors you are going to take, right? So factor analysis is one of the statistical techniques. Basically, it is used to compress your data variables or factors. Sir, I have 50 variables or factors, right? See, listen, you should remember one thing: factor is still variable, where that variable will have a different categorical independent variable. From that, you have to identify by running the factor analysis, by executing the factor analysis, you can get the confirmation that which variables or which items can put under which factor, right? So it is a data reduction technique. In statistical terms, it is called a data reduction technique, where you can compress your more number of factors or variables into a small number of factors, or the factors which is final or which is confirmed for your data analysis, right? So this is a factor analysis. Basically, for that purpose only, we will be doing the factor analysis, right? Because one important thing is you will get lots of variables through the literature review, right? So which one I need to use, or which variables, which term is relevant for my research work. To get that confirmation, we will be using a factor analysis. In simple way, that is the one way that you will be using a factor analysis. So where is that option for factor analysis, sir? There is a column called analyze. You know already, you are started learning how to enter the data in SPSS. What are the options are there, right? And in analysis column, there is a one option called dimension reduction. Analyze, dimension reduction. There you have the option called factor analysis. Clear? So now, for example, okay, there is a store manager and he wants to measure the performance of the store. Okay, but to give a report, because you cannot mention everything, right? You can highlight. You can highlight a few things which is very, very important for your store performance. So he identified, okay, he undergot a research and he collected information from his colleagues and the people who are working in the store and the customers who are visiting their store. Okay, and by seeing the information in the newspaper, okay, advertisement, he collected many things and he got some 80 variables. Right. So my store performance is based on sales turnover, number of customers, frequency of customers, type of product what we are available, what services we are doing, okay, the approach of the customers, okay, availability of the products, okay, so store timing, opening and closing timing, right, and then greetings the employees, okay, discounts, offer, like that. He identified many variables, right? So I can't able to put all the variables. So I need to compress into a smaller number. So in such cases, you can adapt the factor analysis. You can adapt the factor analysis, start exploring all your factors or variables in the factor analysis. It will show you this 80 variables or factors can compress to 5 or 6 or 10. That job will be done by the factor analysis. You have to explore the factor first. Right, after exploring, after doing the factor analysis, the output from the output table, you can able to get the result that all your 80 variables can be put under 7 variables or 7 factor, major 7 factor. That's it. So that means you can highlight that 7 factor. Right, that's why I told you, right? If you're talking about the working time, working shift, working schedule, okay, extra time, all these things can put under the working hours. So working hours includes all these variables, all these items, right? So in that cases, we will be applying the factor analysis. Okay, so clear about the examples. So once started executing the factor analysis, you will understand. Now, when I can use a factor analysis, there is no condition, right? You should have one dependent, you should have one independent. That independent should be a grouping variable. No such condition for factor analysis. If you have variables, that's fine. Either it is dependent or independent. Or the way you framed your research work, what is your outcome variable? Based on that, you can define. But you should have the variables. Okay. So now, sir, can I apply a factor analysis? Because I got 50 samples only. Can I apply? Okay. Don't think that a factor analysis can be applied for a small number or only big number. Okay. According to your number of variables, you can take 5 times of those variables as a count for collecting the sample. For example, you have 10 variables, 20 variables you have. Sir, through the literature review, I identified 20 variables. Okay, but I'm not going to use 20 variables. I'm going to compress this 20 variable, okay, into a smaller number. That means which 4 or 5 major variables or 6 variables or 6 factor is helpful for my research. So if I want to do that, 5 times of your variables. How many number of variables here? 20. So 5 times of a 20, 100. That means minimum you should have 100 as a sample size to execute the factor analysis, because the number of variables that you are going to test is 20. So 5 times of your number of variables should be your sample size. For example, I am using 15 variables. 5 times of 15. Count away sample is enough. But don't think that can I do a factor analysis for 5? No. When you have more than 10, go for a factor analysis. Right? Because already you have 5, then why you want to go for factor analysis? Right? So if you have more variables, okay, then you can go for a factor analysis. Right? But that's why I told you, prefer minimum 10 variables to do a factor analysis. Suppose when this is possible is, sir, I don't have an idea at all. I don't have a clarity which variable or which factor suits for my research work. In that case, you can do the factor analysis. There is a second case also is there. That's why I mentioned there are 2 types of factor analysis. One is exploratory factor analysis, which is called EFA. Explore all your factors or the variable in the SPSS and try to get the output that your 80 variables, your 100 variables can come under 7. Can come under 7 factors. Your 90 variables can come under 6 factors. Explore it and get the confirmation. Otherwise, sir, already I have the factor or the variables to the literature review, And I am damn sure that these are the variables is going to helpful for the research work. Okay, through the literature review, you got that. But to get that confirmation, when you execute the factor analysis, you will get one output called correlation matrix. I'll show you. The correlation matrix, okay, all the values should have a highly correlated value. R value should be maximum. All this should be high degree positive value should be there. If it is negative value, then in such cases, that particular variable is anyway, it is not relevant to your research. You can remove that variable. That is a one way. Okay, that too, when you're getting a confirmation that I got an exact variable and this is my variable is going to use for research work to the literature. Once you get that, to confirm that, you can execute the factor analysis. You can see the correlation matrix. That is the first table column, you will get it. From that, you can able to analyze that whether all the 5 or 6 factors or 4 factors are having highly correlated value or not. Right? So this is a factor analysis. This is a condition when to use, and these are 2 types of factor analysis are there. So this is for an example. So explore. Try to explore all your. Sometimes you may not know. So variable 1, 2, or question number 3, question number 5 can be put under one factor, or can be put under second factor, or variable 3, 4, 7, 8, 9. All these 5 variables can be put under second as well as third factor also. Which one I need to confirm? For that, you need to execute exploratory factor analysis and finally get the confirmation. Yes, under factor 1 or component 1, question number 7, question number 9, question number 3, question number 2 are part of factor 1. Okay, here question number is nothing but the variable. Variable 1, variable 5, variable 9, variable 3 are comes under one factor called factor 1. You can name the factor based on the variables that you are listed in the factor SPSS. All right, so this is what the EFA and then CFA. Right, so see, I already told you, sir, I got the exact variable. Through the literature review, I got the exact variable. Okay, and these are the research variable I'm going to use for my research work. So to get that confirmation, right, so see the correlation matrix. Okay, all the correlation matrix, see, the question 1, all this value. That means this variables 1, 2, 3, and similarly 4, 5, 6, and 7, 8, 9. That means all these 3 variables, 9 variables can put under 3 factor. Right? This question variable 1, variable 2, variable 3. All these 3 things can put under one factor. Okay, see the other thing. Question number 1, that is variable 1, variable 4 doesn't have any high relationship. Sometimes you're getting negative values also. So in that cases, you can identify that these are the 3 variables. Or sometimes this question number 2 or question number 4 can be with high value. In that cases, question 1, 2, 4 can be come under one factor. Like that, you can get the confirmation and you can name for the factor based on the variables that you are listed. All right. So this is a one way that you can do a confirmatory factor analysis. So when I can apply this, sir, I have variables or the factors which I got from the literature review, and I know that these are the variables are definitely used from a research work. It is a confirmation from research work. To get that, you can run the factor analysis, you can see the correlation matrix and confirm that these are the factors are there for my research. This is a one way, right? But most of our research study, most of the people will go for EFA only, because sometimes you may not know. I am not sure that whether this particular questions or this particular variable should put under this factor or not. How I know that? Sometimes variable can be part of 2 factors also. But which one I need to put? That you can get it through the output called rotated component matrix. That is the final output you will get it from the factor analysis. Correct? So this is a CFA and exploratory factor analysis. Now, sir, I have collected. I don't have any idea at all. I have collected the variables, but which variables or which things, which questions which come under which factor, I am not sure how I can able to put it in a right way. So you can run the factor analysis and try to identify that how many variables compress to how many factors or not. Based on that, you can rename the factor and then you can execute the output. Right. So this is what the factor analysis. Okay. So this is what you have to know under the factor analysis. I hope you are clear. Any doubts in the factor analysis? clear about why we need to use a factor analysis, when to use. When you know your variables or the factors, go for the factor analysis through the correlation matrix, try to get the confirmation. And after that also you are not sure, right? So better you can go for explore all your factor and try to identify that your variables can be compressed to 3 or 4 factors or 5 factors. All right. So for compressing to the number of factors, we have to run the SPSS, okay, and we have to give the data and we have to run the SPSS, and there will be a 5 output table, right? 5 output table. Okay. So we will discuss that 5 output table. Please make a note of it. I'm sure that I hope that already you got the sample data also to your mail ID. Okay, please kindly download that data set and be ready with that data set, and also have a note and pen and note down what are the options you need to select when you are executing factor analysis, and which are the values you need to look for interpreting, because that is very important. Okay. Yeah. And now this is very, very important. So there are 5 important terminologies, okay, in the factor analysis, which is called factor. That means it shows that, sir, your 120 variables, your 50 variables can be put under 3 factor or 3 components, right? That is a factor. Factor loading. So how you are telling that this particular variables can put under this factor, or this particular items can be put under this factor or not, based on the loading value, right? Each variable, each items, right, will have a one value, 0.43, 0.34, 0.78, 0.67. All these things are called as a factor loading value. The loading value will be displayed, will be there in the output table for each items or the variables that you are entered in the SPSS. So from that factor loading, you can able to analyze which variables or which items loading value is high for which factor. That you can put it in that particular factor. And eigenvalue. So eigenvalue is talking about that it decides that how many number of factors can be there for your variables. Sir, I had entered all the 60 variables. You entered all the 60 variables. I don't know whether I need to compress 60 variables into 10 or 5. That will be decided based on the eigenvalue. That means which components are getting eigenvalue equal to 1 or greater than 1. That shows the number of factors. For example, 80 variables I entered. Okay, after executing the factor analysis, eigenvalue table, right? It shows that component 1, 2, 3, 4, 5 as eigenvalue more than 1 or equal to 1. That means your 80 variables can be put under 5 factor. That means the eigenvalue determines how many factors you will get it, right? There is another option also in the SPSS. If you want to define, sir, I want to get my variables to compress to 6 factor, you can define by setting a number of factors in the SPSS. That option also is there. Okay, but most probably people will go for identifying the number of factors based on the eigenvalue only, because we cannot randomly, we cannot set, right? For example, we are entered only 20 variables. We cannot say that I need 7 factors. Okay, so in that cases, better you just confirm the number of factors based on the eigenvalue. How many components has the eigenvalue equal to 1 or greater than 1? That decides the number of factors, right? And KMO's Bartlett's test, that is another output. Why this output is very important is, I already told you, explained in the second slide itself, when you have to use it and what should be a sample size factor analysis. 5 times of a variable, right? Suppose, sir, I have used 20 variables, but I didn't collect 100 sample. I collected only 40, right? And try to execute a factor analysis. KMO's Bartlett's test will show you whether the sample size that you are used for doing a factor analysis is sufficient or not. That means your KMO's Bartlett's test value should be greater than 0.6. If it is greater than 0.6, yes, the sample size that are collected for executing the factor analysis is sufficient. So to confirm that also, you can get the KMO's Bartlett's test, which talks about the sample adequacy, right? Now Next part is total variance extracted. Right, for whatever the items or the variables that you are listed in the SPSS, right, whether all the variables are having a variance or having a values more than a certain standard value. You have to fix a standard value in the SPSS option. Right, you can set that value and check that whether all the variables are equal to that value or more than that value. Okay, if it is equal more than the value, you can go ahead with the variables or items. Otherwise, remove those items. Right. So these are the very important terminologies in the factor analysis. Right. Hope you are clear, right? Okay. So now another example I given. So for example, you have some 16 questions with you. Okay, and you have collected the data. So now I cannot decide how many factors can be there for my 16 questions or items. And sometimes there may be some similar terms also be there. It's already told you, right? Working time, working schedule, working hours, extra time, shift time. All these things are talking about the time, working time or working hours. So sometimes similar terms also will be there. So all these things can be compressed, can be sorted out with the help of the factor analysis. Right? That is very important. So now I'll go with the screenshot of what are the analysis you have to do. First, okay, after importing the data, you know how to import the data from the Excel, or directly you can enter the data in the SPSS according to your convenience. From that, after importing the data, go to the analyze column. See the analyze column. In the analyze column, there is an option called dimension reduction. There is an option called dimension reduction. There you will have an option called factor analysis. See, it has been highlighted with the red color rectangle box, factor analysis. So after selecting the factor analysis, okay, you know a new window will open, and all the variables, what are the variables that are entered in the variable view, all the variables will be listed in the left side column. Okay, and you can choose all the variables, click that small arrow and put it in the right side box. Right, that is what the procedure you will follow for all the SPSS data entry and analysis. So follow the same procedure. After that, this is very important. Please have a look and please make a note of it. Okay, so this is the option. I already told you, see in the left hand side, you will have the variable, what are the variables you entered in the SPSS. After converting into the right hand side box, okay, don't give okay. Okay, you have to choose from options to run the factor analysis, okay, in a right way. So there is an option called descriptive. See, there is an option called descriptive. When you open a descriptive option, see, this is the option you will get. Here, you have to choose coefficient. The coefficient tick mark will not be enabled. It will be disabled. You have to enable that. In the descriptives, please make it. I'll repeat once again. Descriptive. There is a options initial solution. Default, it will be enabled. Tick mark will be enabled. But in the correlation matrix, there is an option called coefficient. All right, that is very important for measuring the variances, total variances of the variables that are used in your analysis. So we need a coefficient. After the coefficient, there will be a last option here. It has been hidden here. There is a last option called KMO Bartlett's test. KMO Bartlett's test, because that is very important to know about whether I have a right sample size to execute the factor analysis or not. All right. So there will be another option called KMO's Bartlett's test. You have to enable the tick mark for KMO's Bartlett's test and you continue. This is the first step you have to follow. Okay, I'll repeat. Descriptive option. You have to enable the tick mark for coefficient. Please see the screen. I am just moving my cursor. Tick mark. Enable the tick mark for coefficient. And after that, the last option, there will be a last option called KMO Bartlett's test. Enable the tick mark for KMO Bartlett's test also and give continue. So the first option is over. Now the second option, extraction. There is our second option called extraction. When you are going for extraction, okay, you have to enable the tick mark for screen plot. Screen plot in the sense of which is a strong factor, which is a weak factor. That you can get confirmation from the screen plot. The diagram will show you. So these are the, you are used 80 variables. No, in that 80, okay, 4 or 5 are very strong. Okay, that is much needed for your research. That means that particular research, the particular variables or the items is having a lot of impact, influence on your research outcome. So that's why we need to use a screen plot. screen plot, there will not be tick mark. We have to enable the tick mark for screen plot, right? After that, the eigenvalue is greater than, it will be 1. That is default. It will be there in the SPSS. No need to give value. It will be default. Okay, all these other options will be default. You have to choose only the screen plot and then give continue. So second option is over. Now third option, rotation. Once if you open a rotation, this is a new small window will pop up on your screen, which talks about that none, varimax, direct, oblimini, quantimax, equimax, promax. Here we have to choose varimax. Why? Why I need to choose a varimax? You may ask a questions or you may raise the questions in the mind. I will tell you. Right? I have a variable. I have a many variables, but you cannot say that so this variable can be put under this factor only. We cannot say that. Right? This variable can be a part of factor 1 also, factor 2 also. So I want to make the usage of variance in the maximum level, optimization of variance under different factors, and I want to know for which factor this variable will have high impact. That is why we have to enable the tick mark for varimax. That means variables maximization. Try to show that my variables, okay, variable 1, variable 2, variable 3 can be used under how many factors, or can be used only under one factor. Okay, can you maximize my usage of variables in each factor? It will show you that. All right, that is the one option. The remaining things are all default. Okay, so this is the third option. So first one is descriptive. Second one is extraction. Descriptive, you have to enable the tick mark for coefficient, KMOS, Bartlett's test. Right. Second option, extraction. You have to choose screen plot. Enable the tick mark for screen plot and ensure that eigenvalue is 1 or not. But default it will be 1. Okay, definitely there will not be any other value. And the third option called rotation. Once if you click rotation, ensure that you have to enable the tick mark for varimax. And there is no need to do anything with the scores. And final option is go to the option. Go to the option. Once if you go to the option, there is another window will pop up on your screen. This is the small window where the sorted by size suppress small coefficient will be disabled. Tick mark will not be there. We have to give the tick mark because I want to sort out my variables based on the size. Okay, if you want to compress or if you want to sort your variables based on the size, how you will determine the size? I want to determine my size based on the coefficient. That means you have to set a coefficient. So what should be your coefficient minimum value? So standard in the screen it shows 0.3, but better you can have 0.4. That is standard value, 0.4 or 0.5. If you are using more variables about 20 or 30, set 0.5. Okay, you are using 10 to 20 means set 0.4 because then only you can get the right number of factors. Otherwise, SPSS, the factor will show simply. If you are not determining that what should be my minimum coefficient value, cannot determining, even the variables which got 0.10, 0.002, that also will be under any one of the factor, which doesn't have any impact for your research. Right? It is very, very less percentage, 0.01 percentage. So to reduce that, to avoid that, you can enable the tick mark for the two options called sorted by size, suppress small coefficient. After clicking that, after enabling that, you can set the value, absolute value 0.4 or 0.5. Okay. So clear about the options that you want to choose when you are executing factor analysis, right?
Sir, is it 0.4 or 0.04 you said?
0.4.
Okay.
So after this, once if you are choose all this option and if you give continue and okay, you will get 5 output tables. Make a note of it. You will get 5 output tables. Okay. I will explain you one by one. Okay, how to interpret those output table and then we will go for hands-on training. So now the first output, this is called the eigenvalue output. After the KMOS Bartlett's test output, you will get a one table called the total variance explained table where it shows the eigenvalue. Now see, it has been highlighted with the red color box. It shows that see, you have used 16 factors or variables or items, right? That 16 can be put under how many? 4. Why not 5? Because sir, only 4 components has the eigenvalue more than 1. See the fifth one, it is 0.86. Okay, if you want to make approximately, we can say equal to 1, but statistically we need to take a exact number. In that case, it is not equal to 1 also. So we cannot take the fifth one. So that means your 16 variables, your 16 items can be put under 4 factor. Because the eigenvalue, total eigenvalue variance explained in the table of columns shows that the 4 components as eigenvalue equal to 1 or greater than 1. So this is a first, this is a second output. From this, you can able to know the number of factors. Now you got an idea, sir. I entered 80 variables. From the 80 variables, the total variance explained table or column table shows that my 80 variables can be compressed to 6 factors. I got the confirmation what is the number of factors. Now, under that 4 factors, under the 6 factor, which variables or which question should be there? Whether question 1, question 2, question 3 will be in factor 1 or factor 4. Right? I don't know about that. So next, you have to go to the next output table. This is second.
Sir, excuse me.
Yes, ma'am.
This output just differs in us. I mean, can you run it once again, please?
I'll run. I am explaining the output table. What are the output table you will get? After this, I will explain. I will run the one data set and I'll show you. Don't worry.
Oh, okay.
Okay. And you people have to give me a reply. That's why I'm just showing everything. What are things that we need to choose? Now, second one is screen plot. Now, screen plot, see, sir, 16 things you have entered variables, and in that it shows that 4. That means these 4 factors are very, very important, major factors. All right. So this is the second one. From this, you have tried the output. And the third one is commonalities. Commonalities is talking about the variance, right? So whether, see the output, this is the output table, whether all the variables that are listed having a value, we have set a coefficient value, no, sorted by size and set absolute value 0.4. Just check whether all the values are 0.4. Yes, all the values are 0.4. That means what are the variables you are used for research work, it is needed. But you don't know that which variable should put under which factor, right? Which question should put under which factor, that I don't know now. But I know that all the 80 items or variables that I used is mandatory. It is needed for my research work. I never used any variables which is not relevant or which is not having which is having less impact on my research. I never use those research. I can get the confirmation on those things based on this extraction variable by looking into the value whether it is more than 0.4 or not. This is the next output table, right? And after this, fourth one is component matrix. This component matrix is the output table which shows you which items or variables can come under which factor. Now see the output table. See now. So I entered a 16 questions, 20 questions, right? 20 variables, I entered 20 items. Now, see, already I told you that 20, that 16 will come under 4 factor. Now, see, variable 1, sorry, we say for 17th, 16th, 13 and 2, you can put all these things under 1 factor because this shows that this comes under 1 factor. It doesn't have any impact on the other factors. And now see the 9th one. It shows the value in both of them. That means you can put this variable under factor 1 also, under factor 3 also. Right? But you cannot put under both the factor. You have to put only 1 factor. But that confirmation you can see based on the factor loading value. Which factor loading is value highest? 0.540. Then better you add 9th also in the factor 1. Or still you have a confusion. Right? Then you see the next output table called rotated component matrix that I'll show you. This shows that your variables can put under which factor. The possibilities of the variables under each factor it shows you. Now you have confusion. Sir, this is fine, but instead of putting this second, I can put this 6th variable and then 3rd factor, sir. Why it's showing on 2nd? If you have a lot of confusion, don't worry. There is a next output called rotated component matrix. See, this is the final output of your factor analysis. Now it will show you exact variables under each factor. Now see, sir, 16, 13, 17, 2, 9 can put under 1. 3, 1, 5, 20 can put under 2. 11, 7, 6, 8 under 3. 4, 14, 12 under 4. So now you are clear. Whatever the variables that you are used and you are entered in the SPSS, he started giving the how many factor, and he started giving the which variable items or variable should food comes under which factor. Now you got the confirmation. So this is the 5 output table. Okay, I just showed only the output table. I didn't explain how to write the interpretation. I will explain you now. Now this part is very clear. When to use, what are the factor analysis, what are the options you have to choose, and what is the output you will get. Any doubts in this part, just put your queries in the chat box. Otherwise, we'll move on to the data set. If you have any queries, just put it your message in the chat box. Now you people have to reply, right? When I'm executing the data set, you people have to reply which option we should choose, what are things we need to do. Okay, fine. Now we'll go to the sample data set. Now I have these questions, right? So as a researcher, I want to know the individual's perceptions and their attitude image when they are using a two-wheelers or when they are owning a two-wheeler, right? I want to know the perceptions. So I had measured this with a 7-point scale, 1 to 7-point scale, where 1 is talking about completely agree, 2 is agree, 3 is slightly agree, 4 is moderate, 5 is slightly disagree, 7 is disagree, and 6 is disagree, and 7 is completely disagree. Right? So I wanted to measure this, all these 10 questions, 10 items with a 7-point scale. So I asked question. Okay, first question talks about that I use two-wheeler. Right? I use two-wheeler. Whether it is affordable for me. Okay, yeah, and it gives a sense of freedom to own a two-wheeler. Okay, and it is a very low maintenance cost for me. Right? All the things are asked questions. Okay, right? So now this is a question, and I'm going to execute this with a dummy data set. Okay, I'll run with 10 samples alone. Don't say that, sir, you told 100 samples. I'm just for working for the explanations, I'll work with the 10 data sets, because entering the data will take a time, or importing the data will take a time, right? So I'll explain with the 10 sample data set and how to get the interpretation, how to interpret it. Sir, is there any possibility to get negative values? Yes, you will get, sometimes you will get negative values. In that case, that means that particular variables has a less loading value, factor loading value, which doesn't give a much impact for your thing. Okay. No, more than one, it will not be there. Okay, what is the value correlation? Or it lies between -1 to +1. Okay, it's very rare in getting more than one and all. Maximum one, that's all. Right? You will not get that. Fine. Okay, so now this is a sample data. Now I will open the. Okay. Now can you see the SPSS screen?
Yes, sir.
Okay, fine. So now you all know about how to enter the data. So as per this question, this is a question. The Word document, this is the question. This is items. So based on this, I entered Q1, Q2. I entered. If you want, you can give the name affordable, right? And then use of freedom, right? Then maintenance. Like that, you can keep entering your variables. Okay, what are the things that you are using in your question? And I enter the values also. I given a values. You know how to enter give the value labels. So by clicking this, you can give one label. You can be completely agree, and then add to agree, like that. You can give, and you can give okay, so that the value labels will be added, right? And it's all like ordinal, like a rating scale. Okay. So I entered like this, all this 10 variables. Okay. So after entering, go to the data view. Now see, all the 10 variables are available, and I entered the response also. Okay, just for 20 samples I entered. Okay, what is the response given by the first person? Okay, whether he has given a 1 or 2, or completely agree, disagree, partially, slightly, moderate, whatever it is, I entered. Right. So now I had entered the data, right, both in variable view as well as data view. Right. You are clear with the data entry part, right? I wanted to explain once again, because already you are trained in that in the last 2 days. So I'm just skipping that part, I had already given the data in the SPSS, and then I'm using the same sheet, right? Now, so after entering this, if you want to check that, sir, I want to make it as a label, means just give the value label. There is an option called value labels. If we click, it will show how many people said completely. All this also will be there. Okay. So now, now can we execute the factor analysis? Okay, now can you tell me where is the option where we have to choose? Anyone? Analyze. Very good.
Dimension reduction.
Dimension reduction.
Factor analysis.
Factor analysis. Very good. Very good, ma'am. Thank you. So now once if you give factor analysis, now see, this is the window you will get. Okay, now see, what are all the variables we entered? No, all the variables will be listed in the left hand side. Now you choose all the variable and click this right arrow mark and move to the right side box. Okay, now it is done. Now any other participants, can you tell me what are the options we need to choose under descriptive? Anyone? Give chance for others also. Anyone?
Coefficient and the KMO Barrett tests.
Very good, ma'am. Thank you. So descriptive. See, I already told you, once if you choose the option called descriptive, the other options will not be disabled. You have to enable the tick mark for coefficient, KMO's Bartlett test, which is very important to know whether our sample is sufficient or not. Okay, very good. So as ma'am told, coefficient, KMO's Bartlett test I had given, and I given continue. Okay. Now next participants, can you say what are the options we have to choose under second option called extraction?
Correlation.
Scree plot. So in the extraction, scree plot. Right. Now I already told you, right? We can determine that how many factor I need. Right. I told you, right? Whether you can get the confirmation, okay, by running the factor analysis. Otherwise, you also can define, sir, I need 10 factors for my variable. Okay, I'm using 80. I need 10. I don't want 5. I don't want the SPSS to give me 5. I need 10 means you can determine how. There is an option called, see the extraction option. There is an option called, after the eigenvalue, there is an option called fixed number of factors. Right? That dot is not enabled. It is disabled. We can enable. I enabled now. Then I can set. I need 5. I need 7. You can set. Right? So if you are setting, it will not show the eigenvalue. You can determine that, okay, suppose I need the exact factor, better go for the based on the eigenvalue. Right? This is very rare case. Okay, if you are using more variables, you can fix. Or if you want to show your study with, I have done with more variables, or all those things that you can do. So it's up to you. Right? Right. So this is the one option is there. So you can determine or you can set. This is the factor I need. Otherwise, let the SPSS itself gives number of factors for my variables. Better go on based on the eigenvalue. Okay, now ensure that eigenvalue will be greater than 1 only. So only choose the screen plot and give continue. Now, next option, rotation. Now, next participant, can you tell me what are options we need to choose for rotation? Under rotation option, which one we have to choose?
Sir, Varimax.
Varimax. Thank you, sir. Thank you. So Varimax, continue. Right. Scores, I already told you, no need to choose any option. And there is a option called option. There is a final option. Here, what we have to do? Next participants. Which options we have to choose?
Enable sorted by size, sir.
Enabled sorted by size. Very good, ma'am.
Suppress small.
Suppress small coefficient. Very good, ma'am.
Coefficient.
Now, see, after enabling suppress small coefficient, only it will ask you what is the value you want to set. So I already told you, better set 4 or 5. Right? Don't go more than that. If you are going 6, 7 and all, then you will not get variables. Okay, getting a variable to the test result is difficult nowadays. You can be able to identify which is the exact one. All right, so better have 4 or 5. Okay, so I am setting 4. Okay, and then give continue. Now, what all the options we need to give, we have given. Okay, we are successfully given, enabled all the options, and we are given. Okay, and now after giving everything, give okay. Once we give okay, the output table is running. Okay, Now, can you see the output table? Can you see the output table?
Yes, sir.
Okay, very good, super. Now see the correlation matrix you are getting. All right. So I don't want to follow the correlation matrix because I want to find out that which are the variables. So better. Now the first one is KMOS Bartlett test. Can you see the KMOS Bartlett test output table? This is the first output table. All right. So just see the KMOS Bartlett test value. Okay, it's called Kayer's Mayer Alkin measure of sample adequacy, 0.618. Now tell me whether it is greater than 0.6 or not. What is your interpretation? Any participants? What did we discuss in the KMOS Bartlett test? It should be more than
0.6, sir. So
0.6,
now here
very
it
good.
is more than 0.6, so it is accepted.
That means the sample is adequate. Okay, now first output table is done. Now see the second output table. Commonality is already told, to find out which variables, question 1, 2, 3, 4, 5, 6. It's not having a less than 4 at all. See, okay, all are more than 4. Okay, fine. But only one value is 0.452. That means that shows minimum impact for your research outcome. But anyhow, it doesn't have a negative values also, so we can take that. Okay, we can consider as of now till we didn't get see the rotated component matrix. And now see the third output column called total variance explained. Now can you tell me how many your variables are compressed into how many factors? How many components are having eigenvalue equal to 1 or more than 1? Yes.
3.
See the 3. Very good, ma'am. So see 3.8, 2.7, 1.375. So almost the fourth one is 0.945. We have to take exact value. So all your 10 items can be put under 3 factors. That means you got the confirmation that I will get 3 factors. Now number of factors confirmed, right? And the same thing screen plot also showing which 3 factors are strong, which are weak, right? That's it. Now see the component rotation matrix. Now see, so all this question number 7, 4, 6, 5 can put under 1. Question number 1, 8, 9, and 2, right? Not 2 or 3 can put under factor 2, and number 2 and number 1. Number 2 see it's showing minus. Here see question number 9. That particular items can put under factor 2, but if you put under factor 3, it does not have any impact at all. It's negative, not all relevant for that particular factor. So from this you can confirm, but still I have confusion. So now you have to go for rotated complement matrix. Now see, this is the final thing. So I can put 7, 4, 5, 6 under 1, 9, 8 use of freedom maintenance under 2, but maintenance use of freedom is having negative, so it doesn't have any impact. So you can remove it. And maintenance and question number 10 and then affordable can put under number 3, factor 3. So now you got this. So these are the output, right? Now I'll show you the PPT. Already I have copied this output in the PPT. Now I'll show you how to write the interpretation. Now can you see the PPT?
Yes, sir.
Okay, fine. Now this is the output we got, right? 0.678. Now, so by seeing this output, you have to write the interpretation like this. KMOS is an index which defines a sample adequacy. Here the KMOS test value is 0.618, which is more than 0.6. That means you can consider this sample size. It is acceptable and you can proceed with the factor analysis, right? And the significant value 0.000, which is less than 0.01 or lies between 0.1 to 0.05. That means you are accepting the alternate hypothesis. That means you are rejecting null hypothesis, accepting alternate. That means there is a relationship, there is a correlation between the variables. That means what are the variables you are using for research work is fine. It has impact. It has a relationship for your research outcome. Okay, so this is a first output table you have to interpret. Right, KMO Bartlett test is very important test to know about the sample adequacy, is whether it is this much sample is required to run the factor or not. So this is the first output table. Clear? Now the second one, what is the second output table? Eigenvalue, commonalities. So see all the 10 items are having more than 0.4. The coefficient is more than 0.4. Right? So nothing to worry about it. Okay, no need to remove. 45, this is output. It will show you in the output column. Okay, you know degrees of freedom, right? N minus 1 into n minus 2 is the two different variables. Based on that, it will apply. If you are using manual calculation, you have to use either n minus 1, or if you are going for a significant case, n minus 1 into n minus 2. That is what the formula. But here, no need to worry about the manual part and all. SPSS will give you the output. If you work out manually also, you will get the same thing. Okay. Okay. Now, after this, so the second, the commonalities table. Now, after this, for this, how try the interpretation. Now, see, this is how there you are trying the interpretation. Every variable in the commonalities, okay, having a variance, and those variants are having more than value as, okay, 1. That means this commonality initial values are 1, and they have a extraction value ranging from 0.95 to 0.45. That means you have to write the highest value to the lowest value. What is the highest value? See, 0.95, and the lowest value 0.42. Right. So this is a variations, okay, of your variables, right? And then shows the maximum variance of 95%, minimum variance it shows 45%. That means you are converting this value into a percentage, right? So this is a one output table. You have to write interpretation for the extraction table, okay, for explaining the commonalities. And the third one is eigenvalue table, total variance explain table. Now see, so now I had bolded the first 3. That means the 10 items can be put under 3 factor. 10 items can be put under 3 factor. Why? Because this only the 3 factors as the eigenvalue more than 1, equal to 1 or more than 1 should be there. So factor 1 3.8, which is more than 1. Factor 2 2.77. Factor 3 1.3, more than 1. And it has this variance. It has this percentage. Right. So with this, you can write the interpretation like this. Total variance contributed by first component. What is the first component total variance? 3.88. 3.88. With second component 2.77. By third component 1.375. Right. And then the eigenvalue for given factor measures the variance in all the variables, which is accounted for 1 by that factor. That means all the 3 components has eigenvalue more than 1. Right, and it is clear that all the 3 components are having greater than 1, and the eigenvalue is the same, 3.883, factor 2 2.77, factor 3 1.375. So you can explain the eigenvalue detailedly for each factor and mention the eigenvalue and say that all the 3 components are having a greater than 1, okay, which proves that eigenvalue, and it shows that it's getting a confirmation on the number of factors. Correct? This is the output. And the next fourth one is screen plot. So this is a screen plot. So the screen plot, X shows the components, the items, and Y shows the eigenvalue. Right. So eigenvalue for the first one is 3.883, second one is 2.77, third one is 1.375. That means the maximum is 3.883. And followed by that, the second and then third. And since all the factors are having less than 1 as an eigenvalue. Right, so that means which shows that the components which has more than eigenvalue as 1, all these things are called as a strong factor. That means those factors are much needed for your research. Under that particular factors, you can compress all your categorical variable into that particular part and make it as a one single factor. All right, this is a fourth output table that you have tried. And the next one is fifth one, the last output table, rotated component matrix. Now already this is the output table we got, and this talks about factor 1, this talks about factor 2, this talks about factor 3. Right. Now if you want to see here 0.604, 0.594, which factor I need to put the third item, whether I can put it in second or I can put it in third also. Okay, but to get the confirmation, finally go for the rotated component matrix and take the one value. Right. Now you cannot stop here itself. After this only the climax is there. Right. You have to define your factor. That is very important. You know variables, but if you put 7, 4, 5, 6, all these things under one factor, what I can name for that particular factors? That is very, very important in the interpretation of the factor analysis. That shows the 100% effective of using factor analysis. It's not like running the factor, getting a number of factors, getting a strong and weak factors. I got a very good screenplay. All those things doesn't matter. The final output table, okay, how you are interpreting is very important for your research. Now, you have to take this final output table and you have to create a table, okay, like this. I'll show the next slide. See, now take the first one, factor 1. See, question number 7 is there, right? Question number 7, 4, 5, 6. I will go to the now see question number 7, then 7, 4, 5, 6, 7, 4, 5, 6, right? So these are all the factor 1. So I will mark with the red color. Okay. Now see, fourth one talking about a two-wheeler is essentially a man's vehicle, and I feel powerful when I'm using two-wheeler. Some of my friends who have their own vehicle jealous of me. I feel good whenever I see ad of two-wheeler in TV or newspaper. Okay. So all these 4 items, right? It's all talking about one common factor. You can name the factor accordingly. So see the PPT. Now, all this factor, it's talking about something is of feeling proud and pride. Using a two-wheeler is convenient, comfortable, and when I'm seeing ad in the newspaper, I'm feeling something proud and pride that I need to buy this two-wheeler. And when I have this two-wheeler, when I own this two-wheeler, my friend is jealous of me. All these things are talking about one common factor, or can be determined, can be defined by you, called pride or proud. You can define, right? So now question number 7, feeling good. Question number 4, lifestyle. Question number 5, powerful. Question number 6, feeling jealous. All these variables can be put under one factor called pride or proud. Now, after this, you write the factor loading value. This factor loading value is from the rotated component matrix. This value only. I didn't create any value. This value I just copied and pasted here. That is the rotated loading value. And percentage of variance. Percentage of variance, you will get it from the eigen value table. This one. See, this is the eigen value. Percentage of eigen value is 38.828. This 2 value only I had mentioned here. So you have to open a new table like this. SPSS will not give the output. Please understand. Your output stopped here itself. That's it. From this, you have to form a new table, define your factor, and then explain that how much it is influencing. Now, after this factor 1, right, factor 1, the eigenvalue for factor 1 is 3.833 with 38.828% of variation. The variables are related to pride or proud. So the factor 1 has very significant loading on variable called feeling good, 97%, lifestyle, 97%, powerful, 96%, feeling jealous, 94%. That means all these variable items are influencing on the single factor called pride or proud. That means it is having a high loading, 0.9, 97, 96, 94. So this is very, very important because see the title of your research, perception and image of attributes of two-wheeler owned by the individual. So in that cases, these are all very important variables. If you know that whether they are feeling good, sir, using this two-wheelers, they are part of their lifestyle. All these things are talking about like something they are feeling proud and pride moment for them, right? Usually when we see any actors or the sports people using BMW, we will see, right? Okay, their lifestyle, and they'll be feeling good. I'm owning BMW, I'm owning Royal Enfield, right? Fine. So this is variables are having highly influencing on your research work. So this is factor 1, right? Now next table, factor 2, because your variables compress to 3 factors. We have interpreted for the factor 1. Now for the factor 2. Factor 2, which are the factor 2? Now see question number 9, 8, and the 2 is negative, so we can delete, we can remove, no need to consider 9, 8, and then 3. So see the question, 9, 8, and then 3, 9, 8, 9, and then 3. So I will mark with a green, green color. Okay. Now, this 3 items talking about low maintenance cost, okay, and making economically to run the vehicle. And the 8th one is my vehicle gives me comfortable ride. I think 2 wheelers are safe, comfortable, low maintenance. So all these things can put under one factor name called, you can choose any one. I have given lot of options: convenient, comfort, maintenance. All right. If it is safety, comfort, and economically, it is convenient for you. So I'm feeling comfortable, sir, because the usage of petrol, the maintenance is very simple for me, and I'm very comfortable when I'm riding Royal Enfield. I'm very comfortable when I'm sitting and riding BMW. So the factor 2. So you can mention the factor loading, which you can take from the rotated components matrix. Okay, if you have negative value, remove it. Okay, that doesn't have any impact on a research. And then put the percentage of the variance eigenvalue, which you can take from the total variance explained the table value here. Okay, so this is how you have tried for the second factor. Similarly, the same thing. The factor 2, the eigenvalue for factor 2 is 2.7 with 27.77% of variance. The variables related to factor 2 are convenient or comfort, which has significance by the variables called safety, comfortable, economically, 88%, 84%, and 60%. This is the interpretation for factor 2, right? And now the last one is factor 3, because it has given 3 factors. So the last factor 3, right? Now factor 3, okay, we already included 3, question number 3 in the 2 itself. So no need to consider 0.594, because 0.604 is the highest factor loading value, comes under factor 2. So we can need to put under factor 3. Now we have only 2. Question number 10, question number 1. Okay, now go to the questionnaire. Question number 10 and question number 1. All right, I will highlight with the orange color, and now see, question number 1 and 10 talks about, I use 2-wheeler, it's affordable, and the 3 people should be legally allowed to travel on a 2-wheeler. So it's talking about the certain regulation and the condition and the futures. Okay, so now I can able to define my variables factor with the term called utility or functions of futures. That means I use 2-wheeler, which is affordable. Usage, according to my usage, it's comfortable for me. It's affordable for me. I'm using on a regular basis, so it's affordable for maintenance, petrol, all those things. And similarly, I'm following a certain regulation, certain features, how to use the 2-wheeler, okay, in certain aspects. So I'm mentioning utility or functional features. You can define. So that comes under 2 variables. It's loading value, its percentage of variance, and its eigenvalue. Now, similarly, you have tried the factor analysis for the factor 3 is with eigenvalue 1.375 with 13.74% with the factor called utility or functional features of factors with the significant loading of 2 variables called legal regulations or rules and regulations or futures or conditions and usage or affordable, mentioning the percentage 87 and 78. So like this, you have to explain, you have to take and write the eigenvalue, percentage of variance, rotated value for each factor separately and interpret your factors. And then you conclude your factor analysis. So this is how you have to do a factor analysis. So I had explained you for the 3 factors. Similarly, suppose you have 4, you have 5. Keep explaining, keep interpreting those 4 and 5 factors and project that these are the 5 factors which is having a high influence, confirming that this is a 5 major factors from a research work. Right? So this is about the factor analysis. Okay. So that's it about the factor analysis from my side. Okay. Any questions, any queries you can ask. And one more thing is I had sent you a sample data. There is a, I will show you, wait. I had sent one sample data. Can you see the folder? Okay, please, this is a sample data. This is another sample set I had given you. Okay, and please go through the sample data. And the sample data in the Excel it is available. See, for the 14 questions, I had given a respondents, 20 respondents, 20 sample sets are given. Okay, which respondents has given option 1 strongly agree. I had given this in Excel sheet. Please go through this. You can directly import this data and execute the factor analysis. Okay, and then find out how many factors you're getting, how many you can able to confirm, and then redefine or define your factor according to the variables that you're having for your research work. Okay, so that's it about factor analysis from my side. So now it's a time open for question and answer. If you have any questions, you can ask. Any questions? Yes, sir.
There's a question in the chat box.
Yes, sir.
When we are using already approved scale, is it necessary to test the factor analysis?
It's not necessary, but if you want to get a one confirmation, okay, that's why I told you, you can see the correlation matrix and you can check whether it is the right factors or variables for the research work, because sometimes your variables may differ according to the context or the targeted responses what you are doing. Okay, so if you are already proved, mostly approved one, we will not test. But for your satisfaction, okay, for give a justification, you can execute and you can confirm with only the correlation matrix. See, this is a table you will get, first table. With this, you can get the confirmation. Now see the same example. See the same example. See question number 1, 2, 3. See 4. Okay, question number 3, and then question number 4, and that's it. And the question number 4 can come under 8.9, 8.8. That means 4, 5, 6 can be one factor. So like that, if you want, you can get confirmed. But that's why I told you, no, unless until getting a right factor or the variables through the literature review, which is already proved, you can check once again with the correlation matrix and you can confirm. Otherwise, if you are not sure, try to explore the factor and go for a factor analysis and get the confirmation.
Participants, any more questions are there? If you have any questions, kindly raise your hand. We are happy to unmute you. And you have an option to unmute as well.
Sir, every aspects were detailedly explained, so it was all very clear, sir.
Thank you so much, sir.
Thank you, sir.
Thank you. With that note, thank you so much, sir, for a very detailed and elaborative session. And dear participants, we will meet on day 5 tomorrow. Professor Arun Prakash is a resource person tomorrow to take over. So kindly join the session on time. We will meet tomorrow. Have a wonderful night. Thank you so much.
Thank you all participants.
Wish you the same.
Thank you, sir.
Thank you, sir.